Good afternoon, everyone, and welcome to this session for the .NET Summit 2020 online edition. My name is Alex Thissen. I'm a cloud architect at a company called Xspirit in the Netherlands, and I will be taking you on a 45-minute journey discovering Dapr, the distributed application runtime, and show you how you can build distributed applications as a .NET Core developer. We have a pretty packed agenda for today. The goal of today's exercise and session is to create a Twitter leaderboard. The Twitter leaderboard will show the user accounts that are most mentioned in combination with a certain hashtag. And this is what the end result will look like. We want to have a list of the top 10 accounts with all the number of times that they have been mentioned. Now, to build that, we will create a distributed applications, and it consists of two moving parts. First of all, there's a Twitter monitor that will get the filtered stream from Twitter, watching for hashtag Microsoft, and it will send all those Twitter messages to another part of our application that handles the users that are mentioned most. So we will keep track of all the counts and provide a leaderboard with a web API. It will store some data in Redis cache, and we need to communicate between the two of them. But since this is a distributed application and we want to take it a step further, we would like to use some cloud components and also not do direct communication, but a decoupling with a service bus. And to update the user interface without having to poll or refresh the page, we will be using Signal R server to send out notifications from the component that keeps track of the leaderboard and notify the user interface that the leaderboard has changed. Now, to get started, let's first have a look at what the difference is between a service mesh and Dapr as an application runtime. Service meshes take away all the concerns that you might have regarding networking. So it's about your infrastructure and the traffic that goes from and to your services that run in your application. It takes care of authentication, provides some additional details like telemetry and metrics, tracing information, but they don't allow you to interact with the mesh itself. So there's no programming model. And you might know some of them, such as Istio, Console, Linkerd. Dapr, as a distributed application runtime, does focus on us as developers. It provides a programming model to interact with the building blocks that it provides. And those building blocks offer new functionality in addition to your application runtime, such as interacting with Twitter or with Signal R, storing data, publishing subscribe structures, without having to know all of the details of the building blocks themselves. Dapr itself is written in the Go language, but you can program in a bunch of languages and frameworks. We will be looking at .NET Core, but there are other choices, so it's Java, Python, C++. And you are given a set of building blocks. There's a set of capabilities to do service-to-service invocations, so calling other services, and there's an actor programming model. And in addition, you can choose to have one or more components that allow you to add additional functionality. Those are input and output bindings and receiving triggers from the outside world. There's the publish and subscribe structures, secret stores, state management, and also tracing. Dapr itself can run on any of the major cloud providers because it will use a Kubernetes cluster to run in production. And wherever you have a way to spin up containers and use Dapr in conjunction with that is a place where you are allowed to run your application using Dapr. And the components that you use provided through Dapr can live in each and any of those cloud providers and even a mixtures. So Dapr itself is actually a really portable way to build your application and allow it to be hosted just about anywhere with components that are hosted even outside of those places. The strategy that Dapr takes is to use a sidecar architecture. And the sidecar is the bit of functionality that Dapr provides that is attached to your application. So take your .NET Core application and Dapr will provide you with a sidecar. The sidecar and your application are merged together at runtime, so they are connected and they will communicate back and forth with APIs. Dapr itself has an API and your application must provide an API as well. So they know of each other, but they don't have the code merged together and they are communicating with API calls. Now, if you want to run this in Kubernetes, you can actually see how it is intended to be used in runtime. Dapr itself, if you install that inside of a Kubernetes cluster, will give you a set of pods. And the most important ones are the sidecar injector and the operator, which should take care of creating sidecars and providing the components. And your application, when it starts, will spin up a pod with your container image containing your code. But because there are special annotations in the deployment manifest, the sidecar injector pod of Dapr will inject a sidecar and connect the two together. It will do that for each and every of the components of your application in your distributed composition and inject those sidecars wherever those annotations are found. And after these sidecars are started, they know how to discover each other through MDNS, and they can talk securely to one another with mutual TLS if you use the certificate authority in the Sentry pod. The sidecars know how to communicate with each of the components and building blocks that are available through Dapr. And this is kind of how it works. So let's take any piece of application code. Your application code will talk to the sidecar through the Dapr API. And the Dapr API has a set of well-defined versioned endpoints that correspond one-to-one with each of the building blocks. So if you want to use the building blocks, you will communicate with the sidecar through each of those endpoints, and you will make calls through gRPC or HTTP to the process that is hosted inside of dapr.d.exe. That's where the sidecar lives. So they're separate processes, and in a Kubernetes cluster, they will be running as two container instances inside of one single pod. Now, the building blocks for service-to-service invocation and the actor programming model are provided anyway. But for the components, you need to define which components you would like to use. And the actual details of those components is abstracted away. So you are only concerned with, I want to use a publish and subscribe component. Which one it is can be a variety of things. There's all these community contributions that are added to Dapr, and the list of choice that you have is growing by the month. The way you define those components is in a declarative manner. So that's inside of YAML files, text-based, that live in your code repository, but are not part of your build process. It's only deployed to the runtime situation. And it allows you to swap out the component definition files even after deployment. So you can move your components around and pick another component that's in the list. There's a whole lot of choice for state management. There's even more for distributed tracing and for secrets. And we will look at the large list of resource bindings and triggers a bit later on as well. Now, the way those components are defined is in the YAML files, and they follow the same structure as deployment manifests for Kubernetes. There's a component with a certain type that you can find in the specification here. And in this case, it's a Zipkin exporter. So a component that allows you to export all the tracing information to Zipkin in this case. And the metadata contains the connection details. And those might differ from component to component. You can have multiple component definition files. And in general, you will have one configuration file. And at the moment, you can specify only a configuration for tracing with a sampling rate. And the sampling rate in this case is 1, so it takes 1% of all the trace information and sends it to the registered trace component. In this case, we see it on the left-hand side is Zipkin. And the annotations that we talked about earlier for Kubernetes, they are Dapr.io, and it has a number of different aspects. So whether it's enabled or not, a unique ID for your application and the port that your application is listening on, we will see that more across this presentation that the ID and the port is very significant. Now, to get up and running, and this is focusing a bit on the development side, on your local development machine, you will install Docker Desktop. And with that, you will also get a local Kubernetes cluster that allows you to run your application in Kubernetes as it's intended to be running in production as well. Also, you will install the Dapr command line interface. And Dapr comes with this rich interface that allows you to interact with everything from the runtime. Locally, you can start and stop Dapr instances if you run in standalone mode, so that's without any cluster. And for Kubernetes, you can see and interact with the cluster and all the Dapr components that are living inside of it. And then finally, after you've installed the Dapr CLI, you need to initialize the Dapr runtime. That can be locally, so the Docker desktop will have a couple of containers running, providing the base services, such as placements and state storage. And in Kubernetes, you will need to use the Dapr CLI as well, or you can use Helm charts, whichever one you like best. Now, if you're running locally with the sidecar, then that's very good for development purposes, because you don't have to deploy everything inside of your cluster, and even debugging becomes a bit easier. So take your .NET Core project, and this is part of the project that we will be looking at. That's the Twitter monitor. You can run this application once it's built with the Dapr command line interface. So that's Dapr run to start a local running Dapr instance. And what it does, it will spin up your application. That's the command at the end, .NET run. This is the traditional way to start your .NET application. And it will attach the sidecar as we saw before. So what it does is it will know what the unique ID of the application is, and also which port is exposed and that the sidecar expects to find on your application. It will discover all of the components wherever you specified. So that's in the components path in the command line instruction. And then it will start waiting for port 5000 to become available. And once that's there, it will expose its own Dapr API, so your application can call into the Dapr API, getting access to those discovered components that were registered. If you want to talk to the Dapr sidecar, you need to use all of those endpoints, but they are URLs and it's gRPC or HTTP traffic. As a .NET Core developer, you're accustomed to working with assemblies, NuGet packages, and the mechanics that you know from ASP.NET Core and from .NET Core. And you will find those. So you get builder extensions, you get the state model binding to make it easier to bind to the states, support for publish and subscribe and the actor models, and even for the configuration to load all your secrets in there. And an important one, a Dapr client that allows you to interact with the Dapr sidecar on a strong type basis. Now, let's see some code and things happening. This is the application that we want to build. And for now, we will be focusing on the Twitter monitor and see what it takes to bind to Twitter and get this filtered stream of #Microsoft. Now, to do that, you can use input and output bindings. And in this case, it's an input binding. There's a whole set of bindings that you can use, and you will define, as you can see in the component definition file on the right, that in this case, it's a binding to Twitter with connection details from your API registration. And finally, at the bottom, there's the query, and that's #Microsoft that we'll be using. Now, this is a registration for the sidecar that your component, a component that your sidecar will register, and it will start a connection with Twitter. And whenever there's a Twitter message received, it needs to send that to our application code. And because we have an API, it will call an endpoint on the API. And that's an endpoint that corresponds to the name of the Twitter component that we registered. And that was tweets. Now, there's two ways of doing it. We will be looking at the top one with registering an endpoint in the startup of our ASP.NET Core application, but you can also do it the MVC way with a controller method that has an HTTP post with the same registered endpoint, and then you can handle the incoming data there. So let's take a look at how we set that up, how we go from our application that is a Twitter monitor that works to using a sidecar and receiving all of those incoming Twitter messages from the stream and dealing with them, handling that with a bit of logic. Now, in order to do that, I've gone into the code repository and we're inside the project for the Twitter monitor. And you can see here that everything is there. First, we need to get everything up and running. And let's see if we have Dapr there. That's the command line interface. And as you can see, here's the command line interface. And we can also ask which versions are installed. And as you can see, we have the CLI version and the runtime version. So we should be able to get everything up and running. Now, next, we will have a look at what we actually built. This is the project. It's a .NET Core 3.1 application. And in our program CS, we see that this is just the default way of bootstrapping your application using a startup class for ASP.NET Core. And in the startup class, the most important part for now is that we will be registering an endpoint where we want to receive the incoming Twitter messages. Now, we needed a definition for the input. And this is the same definition that we saw on the slides, where the name of the component is tweets. It's a binding to Twitter. And since this is in our structure for our project, we can have the sidecar discover these definitions. And in the startup, we use that name of tweets to register a post endpoint and dispatch to this Twitter message handler. And the Twitter message handler, and the most important part for now, is that we deserialize the incoming body of the request. So it's a bit raw, and we deserialize that into a tweet structure. And the tweet structure is listed here. And as you can see, there's a lot of data in there, but we will be mostly interested in the user mentions that are listed here. And that's a separate structure as well. So we have a little object model for the data that we receive. And when we start this application, the sidecar will call into this endpoint when it receives a Twitter message, and we can start handling it. Now, instead of running this from Visual Studio, I will start it from the command line interface. So what I will do now is start this application, and I will use a unique ID for this application, monitor. I will tell the Dapr runtime that our application will be hosted on port 5000, and that the components path is the components folder inside of our directory structure. And we do a .NET Run to fire up everything. Now, once we start this up, you will see this yellow output. That's the output from the Dapr runtime. It's now waiting for port 5000, as you can see here. So it's waiting for our application to become available. And I will shut down the application running in the backend, because otherwise that port is not available. Here we can see that it found a set of 3 components for the state store, the tweets, our binding that we defined and that we will be using, and also for a message bus. But now, for now, we will be looking at these tweets. It's waiting for the application to start up. And once it's started, it will know that the application is available. As you can see now, it has discovered the application, and then it starts bootstrapping the rest of the application. So now we're up and running, and we're waiting for Twitter messages to arrive. And we need to be a little bit lucky here to have actual messages coming in at this very moment, but let's just wait a little bit and see if we can see some output from the logs that were inside our application here with the logger log information. I'll leave this running for a little bit and we'll go back to this later on. But this is all it takes for our application to have this input stream of Twitter messages. And notice how there's no code needed besides for the data contract to actually know about how to connect with a Twitter filtered stream, which is not trivial. And there we have already one message arriving. So we see that these messages are actually coming in, which is kind of cool. So I'll shut this down and I'll clean up a bit so we have a fresh start a bit later on. There we go. All right, back to the slides. To interact with the sidecar, we need to invoke each of those endpoints because those correspond to the building blocks from Dapr. In our .NET Core, there's a convenience way of doing this. Instead of doing raw HTTP request building with a strong typed proxy. So we are given from the .NET Core SDK for Dapr, we are giving a set of NuGet packages, and the most important one is this Dapr client. And the Dapr client has an object model that gives you methods for each of those endpoints. So you can use method calls instead of HTTP requests to talk with your sidecar. To register that, you will register it in the dependency injection system, and you will do add Dapr client with a bit of configuration. Once you have it registered, you can resolve it where you want to use it with constructor injection. That's what you most commonly do. But since you won't always need the Dapr client for each of the handling methods that we will be building for many components, you can also choose to have it injected inside of a particular handler method with this from services annotation, and then inject this Dapr client just for this method instead of every time that the class is constructed. And with this Dapr client class, you can do these async functions that correspond to each of the building blocks that we have. Now, for example, you can use it to do publish and subscribe. Now, how does publish and subscribe work from the Dapr point of view? Obviously, we need some sort of message or event bus, and we have a publisher and a subscriber end to it. The implementation for the event bus can be chosen by you. It's one of those components for the bus. It can be Nats, RabbitMQ, Redis, or even Azure Service Bus that we will be using. And on our side, we use some code as a publisher to send messages, but it's the sidecar that will be doing it. So we will instruct the sidecar with, for example, an HTTP call or a gRPC call, or more conveniently with the Dapr client, and it will send the actual message to the topic that we want to put it on. And on the receiving side, we can have subscribers that receive that message. And it don't have to be Dapr-based applications, but they can be. The subscriber code is again called from our Dapr sidecar. When it has a subscription, receives a message, it will call into one of those endpoints that we need to register, much like we did for the input binding. And in this case, the data that is put inside of the message as on a topic is wrapped inside of a cloud events envelope. So there's a wrapper around it with some details and some tracing information for distributed tracing. And it has this data section with the actual payload. So that's the data that we're concerned with. To do a publish of a message, well, there's support from the Dapr CLI, so you can do Dapr publish for testing purposes. But inside of your code, besides that, you can use the HTTP request to, or the gRPC request to your sidecar. As a .NET Core developer, you will probably use this publish event async. And this is the data for the payload, the topic for tweet, and then the actual data. And that will take care of doing everything. And it's the sidecar knowing about all the details on how to connect with the actual components. And remember, that component is defined in a YAML file, which can be changed. So you don't have to know which publish subscribe component that you are actually using. Now for the subscription side, you need to receive the message and you need to unwrap it from the envelope. And that's where you use this cloud events middleware that takes care of removing the outer layer. And there's a subscribe handler that exposes from your subscriber part all of the subscriptions that you would like to have. So there's a particular endpoint, Dapr subscribe, that lists all of the subscriptions that you would like to have. And this is where we have a brief look at how you connect the sidecar and your application together. So the sidecar receives and it posts to a particular handler called tweet, a handler, so that's the endpoint or the route. Then you have the receive tweet handler, much like we had for the handle Twitter message. And then you specify, sorry about that. Then you specify the topic that is there. And the controller action is another way of doing that. It has an attribute for topic on tweets. And you can see that, again, we are using a method with a strong typing for the tweet. That's the data that we receive from the application, from the sidecar. So splitting up the route and topic, it gives you a bit more freedom. Now, before we go into the next demo, so we talked about publish and subscribe. State storage is pretty much the same thing. You can use the URLs, but it's easier and more convenient to work with the Dapr client. You can register various state storage, and they can be of different types. And each is given a unique name that you will find whenever you do a post, get, or delete. Then you will need to specify the store name. And if you want to retrieve or delete, obviously you need to define the key for the actual item that you want to get or delete. Now, it's again, you need to define what is your component, which type is it. So in this case, it's a Redis state store, and it has some connection details. And furthermore, you can have more options regarding the way the transactional consistency is taken care of and the resiliency patterns that are used for state storage, such as retry and back off, where you can specify how you want that to behave. The .NET Core SDK allows you to interact with it in a ASP.NET Core native way, which is using an annotation from state, specifying that store name. And then it gives you this state entry for tweet, where the unique key is provided inside of the route and the variable attribute that is there. And that will get from the state store the data and deserialize it into this structure called tweet, the tweet class. Or you can use the Dapr client. Now, let's look at a demo where we will do those two things together. So we will be using Azure Service Bus to publish, and we will also look at a new project, the Leaderboard Web API project, that has this code for the most mentioned inside. So the logic handling all those incoming Twitter messages. It will store the incoming Twitter messages first, and then do some additional processing. Okay, so this is where we left off. We saw that we handled the Twitter message, we deserialized it into this object with a reference tweet, and now we want to publish that so the most mentioned logic can handle that in another part of our distributed application. Now, in the pub/sub definition, you will find that there's a component called message bus, and the name is not really relevant because at this point in time, you can only have one pub/sub component. That might change in the future. The team is working on that. It has some connection details, in this case for Azure Service Bus in particular. And with that registration, we only need to specify when the sidecar wants to publish a message, what it is that we want to publish. So here we see that we have this Dapr client, and this Dapr client can be used to call this method publish event async. And it uses this object, the tweet received object, publishing the full data of the original tweet, but also this tag. And this is important to remember because we want to know in what context this tweet was mentioned. So it's, in our case, #Microsoft. And then we end with a 200 OK to indicate that the handling was done correctly and that this is now over. So that's that part. Now let's look at the other side where we receive messages whenever they are end up on the other side of the subscription. This is again a .NET Core application 3.1, and we do a bit of startup there as well. And we saw what we needed to do. We need to unwrap using the Cloud Events middleware, and that takes care of removing the information in the envelope. and we need to expose the endpoint to let the sidecar know which subscriptions that we have. And the ones that we will have will be discovered automatically. And in this case, it's given by this single handler method here. This is where our mentions are handled. It's on top on this topic called mentions, and the route in this case is kept the same, because so you can also do a post on this method, but this will indicate to the Dapr sidecar through means of that subscription handler. This is a subscription that we would like to have. And what it does, it deserializes whatever we receive in the message into this thing called tweet received. And the tweet received class contains the actual tweet and the tag. And again, we will focus on the first bit where we say, okay, whenever it's received, we send out this Twitter message. And then for the next part, which is where we use state storage, we will have the Dapr client that is injected here. And we will use the Dapr client to save the state into the store name, which is the state store that we defined in this component here. And that's, in this case, reddish cache to store everything. And then we store under the key where we use the unique identification string for the tweet message, we store that particular message. So this is the part that we will be looking at. But now comes the tricky part, and also a very cool part. Now we have two elements in our distributed application, and how would we normally fire those two together? Well, for local debugging purposes and development purposes, you would use a Docker Compose. And that's what we are doing here as well. So at the very top, we have our usual definition of, we use this image and it's built from the Docker file that is inside of our project. And that's the same as you might have seen whenever you've used the Docker support inside of Visual Studio. Now, there's other things that we need to do, because we need to make sure that the sidecar is also inserted there, but we're not inside of a Kubernetes cluster. So we need to do that manually. And this is the part where we define a second container running in the composition, but tightly connected to the leaderboard web API service. And this is the way they are connected. So with network modes connected to the service of leaderboard web API, they actually start behaving as one entity. So they are connected together. And all of the details that are here are to make it work, to have unique ports inside of our composition that are exposed, so we can talk with it from the outside and also here inside of the environment variable. And this is dependent on the Redis and the placement services if we would want to use actors later on. Now this is the placement servers. As you can see, it's a Dapr provided image that we can use. We could be using Zipkin for distributed tracing. And down here, we have the Redis component that we would like to use. And then we do the same for the Twitter monitor. So the Twitter monitor also has the sidecar here, which is again, a Dapr provided image. In this case, Dapr-D, where we have a different port available. That's 5003 for gRPC. And they are connected in the same way in this network. So with that, and that as our starter project, we can simply launch this total composition of container images and see everything working together. So what it's doing now, it's first building the projects. So we build all the assemblies for the web API and for the Twitter monitor. And once that's done, it will start up the actual container instances and build them all into a Docker Compose, which you can see running now right here. So all of the components are created first, and they are starting now. So most of it is spinning up. And we should be getting a bit of results in a moment. So once this is done and started, it will attach the debugger, and that's the beautiful part of it. So we can actually debug everything inside of this composition where we have the source code available. So that would be the two parts, the Twitter monitor and the leaderboard web API. So now we've done that, the build is successful, everything is firing up for the debug session now. And the debugger is attached. The bar should go orange in a bit, and see, now we are debugging. And we are able to look inside of the logs of the individual things here. So here we look at the Twitter monitor. There's no logs yet, but as it's starting up, it should give us some information on the usual way that our Twitter monitor is bootstrapping. You can also see that there's additional, all the images that we defined in our composition are also available. So we have the leaderboard and the Twitter Dapr versions. And as you can see our application coming alive, you can also see that there's logging available, the yellow part from what we saw from the command line, where everything is starting up now. And the same here for our leaderboard web API, it's running, and all we need to do now is wait and hope for Twitter messages to arrive so we can actually see something happen. But this is the way our complete composition is running inside of Visual Studio, and we can do debugging as we know and love it. So let's put a breakpoint in the Twitter monitor, and we might just get lucky if there's a message coming in. So we'll put a breakpoint here, and hopefully in a moment we will see a Twitter message arriving there. Let's go back to the slides. Now, we've done all this. So we've received, we've stored, and now we want to build the leaderboard. And the leaderboard is this single thing that you can think of as being an actor from an actor programming model. And here we see that we have an incoming message. And just for the sake of the demo, let's see that if we go into the container again and we remove the breakpoint because there's multiple coming in now. So let's continue there. You should be able to see that there's multiple received from the Twitter monitor, and the leaderboard web API is receiving it on the other side. And you can see that we log this thing that the Twitter message has actually arrived on the other side. So from the subscription side. Cool. Now back to the actors. The actors provide you with a programming model that takes away all the concerns that you might have in a distributed situation for multi-threaded concurrent access to your application code. And in the case of the leaderboard, you want to make sure that not multiple components are trying to change the leaderboard at the same time, because that will give us some race conditions, for example, or concurrency conflicts. Now, the actor programming model takes care of that. It's a service that is available by default. If you're using actors, it will make sure that all the actors live on one of the nodes inside of your cluster and that it's available when you need it. Not your concern to know if it's alive or if you need to retrieve it. That's done by the actor model. And only thing you need to do is indicate which one of your state store is the store for the actor data, because each actor can have its own data. And that's the strength of the actor programming model. When you interact with an actor, you can interact one request at a time with the actor, and it can manipulate its own data. So giving the actor access to a leaderboard for a particular tag, hashtag Microsoft, allows us to have multiple leaderboards, each represented by a different actor. And again, we interact with that actor through the sidecar. And we have this endpoint where we specify the type of the actor, its unique ID, and the method that we want to call, because you talk with actors through method invocation. Now let's do that part now as well. So we will look now how we can use our code to, on incoming subscription messages on the bus, how we can store them, and how we can build the web API providing the leaderboard, and the leaderboard itself is taken care of for each of the individual leaderboards by actors. All right, so going back to here. First, I'll show you in our application for the web API that there is a contract that defines the shape of the actor. We have a submit score, which is where we will say, this user has been mentioned so many times, and it will take care of finding out if you actually make it into the top 10. And if you want to know a certain leaderboards, you can ask for the leaderboard based on its ranking, for example, the top 5 or the top 10. And the implementation is here. So here we have the actual class implementing the interface. It's derived from the base class that is provided by the actor programming model. and you need to have a special constructed way of initializing your actor. And then you implement the interface. And when you want to retrieve the ranking, you will use the state manager for this actor to get the state that it has. And that should contain, in this case, under the key of ordered list, it should give you a list of all the entries that are there. And they are called leaderboard entries, which is a list of the unique ID, a name and a screen name, and the actual score. That's the number of times that that user has been mentioned. And to create and update the scores inside of the list, the logic is a bit like this. We have the state manager, which gets, again, all the entries for this particular actor, and it knows its identity, and it has its own state store, so you don't have to filter everything. And it will check if there was already an entry found. It might just be the very first time that we store a value for this particular hashtag. And then we do a bit of logic. And finally, if you make it into the list, we take the top 10 in this case, because our max entries are at 10, and we save this list back to the state manager for this actor. So this is how the actor, it represents the list of the top 10 user mentions that we received. Now, inside of our logic, well, we'll go briefly skim over it, but the most important part is that we need to get a handle to our leaderboards, and we do that with the tag, because that's hashtag Microsoft, so Microsoft, and this unique actor ID allows us to get at a proxy representing the actor, which has the data for the leaderboards. And then we do some logic where for each of the users that are mentioned in the tweet that has hashtag Microsoft, we actually find and increase the number of times that we've seen that. That's in state storage outside of the actor. But then we dispatch that entry to the submit score method of the proxy. And that's where we build up the list of entries inside of our leaderboards. Now, that's all good and fine, but how do we get at that data? That's where we have the leaderboard controller. And the leaderboard controller has this very simple method where we almost do the same thing. We create a proxy to our actor, and we just call this method getRanking. All right, that by itself is enough to get everything running. And we might just put a breakpoint here to see what is happening if we go into this part here. That will only trigger if there are actually user mentions, and we will leave this running, and we might be interrupted by it when the new message arrives. Okay, back to slides. Oh, there we already have an incoming message. So let's see, it should fire up now. So now we can see that there's this unique ID. If we step into this, we go to the implementation of the actor, and we should actually see what is happening under the covers. So if we keep this running, it's actually starting to use the information there now. And we should be able to get at an endpoint for retrieving all of this data. We'll have a look at that later on. So back to the slides. The final part that we want to do is whenever the leaderboard changes, or as might have been changed, we want to notify the user interface to update itself. So we don't have to do polling or refreshing all the time. And in this case, we use SignalR, and it's hosted inside of Azure. So we are using Azure SignalR server. And we have, again, connection details. So this is the component definition file. And whenever we want to send a message to the hub that the SignalR server has, we just do this invoke binding. Now, the model is pretty much the same. You specify your output binding name, and you use one of the methods. And inside of Azure SignalR, it will always be create, and it's not really a relevant name. But this data is the actual data that you want to send to the hub. And here you can see this list of output bindings, that there's many other bindings that you have, and some of them are using the two-way. So you can actually send something, but also receive some kind of response back. Now that's the final part of the demo that we will be using. So we will again look at the leaderboard UI, and see how it connects to the web API that we built. And then how we can send messages from our application code most mentioned, so the leaderboard web API, to the SignalR server that is then pushed into the leaderboard UI, which makes a new call into the web API to show the new list of information. The front end, by the way, is built by my colleague Thijs Limmen. He helped me out there because that's kind of a tricky part for, at least for me as a .NET Core developer. Now, what do we need for that? So in this case, we have this output binding, as we saw on the slides, to Azure SignalR server that we will be using. But first, let me show you the one single file that shows us the front end. And again, as a reminder, we started clean. So if we refresh this, we should be getting a new list of everything that is in there for now. And whenever there's something new coming, it will retrieve the new list. And you see these little pop-ups here that are being pushed by the SignalR server. See, there's one coming. Apparently, there was a message received, but it didn't contain any user mentions that made it to this list. Now, this bit of code here, it uses this endpoint here that we could also be using. So if we take this endpoint and go to the browser again, we should be able to also call that, and we do a top 5, for example. And here we get the top 5 entries that we also see in the user interface that is all prettified. But this is what it's being called. And there's also, whenever there's a message coming in for the updated, from the SignalR, it will update everything, and it will do this leaderboard updated, checking if it's not changing too fast, and then get the leaderboards again and displaying that through binding. So that's all front-end view logic. To get all that working, let's go back, because we registered the component, the output binding, and we know that we can reference it by this invoke binding async, specifying the name of our component. And we need to build this special data structure. And in the case of SignalR, this is what it looks like: the target, which is the method. And then there's this empty list of strings, because we don't actually send any data. We just want to say the leaderboard has updated. And you could be smarter here and do the deltas to make it even more efficient, but it's skipped in this demo. So that data is actually being sent with this invocation call. Now, with all that in place, we saw pretty much of what we needed to do. So this is how simple it is to get that running. You do need a bit of extra infrastructure to get the SignalR hub running. So you will have this bit of middleware registered for the SignalR in Azure, and some dependency injection components. But it's only for the user interface to be able to talk to the leaderboard hub that we have. And this is the leaderboard hub definition. Now, that allows us to get to this data. And you see that it's being updated as messages are received. No refreshes needed. Whenever we had the subscription message arriving on the bus, it's stored. The actor is used for updating the leaderboard, and we push out everything with SignalR to indicate to this user interface that something has changed. And that is the way we build this entire application without having to know much about SignalR, Twitter, message buses, or whatever that we have. And you see that there's even now new messages coming in, but apparently they didn't make it to the top 10 in this list. Now, wrapping up, we will go to what does this give you? Why would you want to use Dapr? Well, first of all, I hope that you see that with minimal amount of code, no knowledge of the actual components, you can accelerate your development. It's also a way to bring more portability to your implementation, because you can run your implementation on each of the cloud providers that allow you to have a Kubernetes cluster, or at least the sidecar architecture structure that Dapr has. And it allows you to have multiple components living in each and every of those cloud providers, or on premises, and even mixtures of the two. Now, Dapr is evolving. It's not released in a 1.0 version, but the team is working hard to get there. They're currently at the 0.9 release, and they will be working towards 0.10 in the next week, and 0.11 and 12 after that. It's being driven by the team itself, but also by community contributions. So each of those components that you saw are community contributions, and the team would love your feedback and have you helping out by doing contributions to the open source code that is available. Now, the source code is on GitHub, so you can find the original implementation, the documentation and samples, and also the code for the .NET Core SDK. The code that I've used in the demo that you saw is available on GitHub as well, and you can get in touch with the community and the Dapr team with the Twitter tag @DaprDev, or when you want to participate in the bi-weekly community calls, where they will do end of sprint reviews and show the community what they've built in the next release. If you have any questions for me, you can ask them later if you want to, or in the Q&A session that will follow shortly. You can contact me at @AlexThissen on Twitter, or on my email address, thissen@xspirit.com. Thanks very much for your attention. Have a lovely rest of the conference, and I hope to see you in a bit during the Q&A session. Bye for now.